Where's my mouse? There we go. All right, Jeff.
Yeah.
FAQs.
So we're going to take a look at the top 10 frequently asked questions. Number one, what are the most common force measurement types? Probably fatigue and structural testing, without a doubt, is probably the most common force measurement type. What type of equipment must be in every test lab? That's largely going to depend on what you're testing. So if you're doing structural testing or fatigue testing, you're going to want fatigue load cells, or if you're doing torsion testing, you're going to want torque cells. So again, that's highly dependent on what type of test lab you're operating and what type of tests you're going to be conducting. What is the best way to preserve measurements taken in a test lab? That's going to largely depend, on your quality system or your accreditation, if you do have an accreditation. Some may require you to keep results for a certain period of time. Others may not, but so it's really dependent on, the quality policies and the accreditation types that you have in your lab. And then what types of tests should be avoided? Well, you certainly want to avoid tests that may impart, harmful loads into your devices, something that may damage the product, damage the load cell, damage the torque sensor, impart extraneous loads and bending loads. Those things should be avoided for sure. Damage expensive test equipment is not a good thing. And how hard is it to get accredited for your lab? Again, that will depend on a number of factors. It will depend on what type of accreditation you're going after. It's going to depend on if you have any sort of quality system in place already, or whether you're starting a lab brand new and you don't have any of those systems in place. That will definitely affect, how hard it is to get accredited for your lab. Elliot, send it back over to you.
Appreciate that. All right. So what are the most common sources of errors in testing, and how do you prevent them? So there's a couple of ones I guess I'd lean to first, and number one is misalignment. Oftentimes misalignment can be the greatest single source of error in an application. Using load cells that are either moment compensated or more resistant to off-axis errors, or just making sure that your assembly is as well aligned as possible is the best way to go about preventing them. A lot of times there are errors that are propagated that people don't know about because it's hard to quantify how much misalignment there is. And other ways to identify if you have misalignment would be if you've got a multi-bridge load cell, you can look at deviation between the two bridges, or you can install some sort of a different type of sensor. You can go to a multi-axis sensor and try to measure what the resultant forces from said misalignment is. That can be a real tricky one, and sometimes testing is going to have that misalignment no matter what you do. How do you ensure that all testing is performed in a safe environment? It's important that you have a good grasp on what the expected and potential peak loads are and peak moments are. That lets you quantify the load string strength, load cell capacity, and best define what you expect, as well as the point at which the DUT is expected to fail. Again, trying to make sure all constraints of that testing are understood clearly. What are sample rates and how do they apply to regular testing? Essentially, sample rates is how fast are you taking data from your measurement device. You want to make sure that you're getting enough samples to quantify the test results you're seeing. So, for example, if you're trying to quantify a test event that's happening over 1 second, sampling once a second may miss a whole lot of data. If you're trying to sample an event that happens over 10 seconds and is relatively static, yeah, that might work. But you want to make sure you have enough cycles or enough samples to completely profile the test event. Typically, you want to have 10 samples across that test event at a minimum. And again, that's going to be highly dependent upon what that event is and what you're trying to look for in that. What should I look for on a calibration certificate? Well, a number of things. You want to look for the serial number. Make sure that you're looking at the correct calibration certificate. Calibration date is always important. And then, of course, looking for the calibration data. What do you get for data on these? Is it a full-scale output? Is it a best fit straight line number you're looking for? What is the zero balance of the sensor? There's a lot of different things that can be gleaned from reviewing the CalCert. But I guess just make sure that you understand what the different parameters are for performance on the cert and what to look for on those in that data. And that kind of relates back to frequency calibrations. So for example, let's say you're looking at the cert from your load cell you just got back last week from your cal, and maybe you're going to look at the cert you got from last year. If you see a big deviation in zero balance, that could indicate that the load cell's been damaged. If you see a big deviation in full scale output from year over year, that can be an indication that the load cell's been damaged and is drifting. The frequency of calibration, there is a definition of how to determine this frequency per ASTM 74 if you wanted to go that route. Essentially, you're looking at stability of output from the load cell over time, and then you're looking at the stability of that output relative to your application and determining if it's going to be suitable for your application. So if it stays relatively close year over year, so you get a 0.01% drift from your first calibration to your second calibration, you can use that to either justify an interval extension, or maybe that's too much drift for your application, so you pull it in. The other one to consider is the usage type of the load cell. If it's something that's a severe or hard duty cycle, perhaps it's used in an impact test or something, you may want to calibrate it more often. And then, of course, criticality of the measurement. How critical is this measurement? Some very critical test type environments will do a pre and post where they calibrate the load cell before their test and then do a post calibration to ensure data validity through the duration of the test. So again, criticality being another consideration there.